Everybody, welcome to my tutorial for learning how to construct and manipulate matrices using Mathematica 10. I'm going to be covering different topics here. Matrix creation, we're going to do matrix transposition, how to invert matrices, row reduction, how to find the determinant of matrices, matrix multiplication, and then we're going to finish off with how to use Mathematica to find eigenvalues and vector spaces of transformation matrices. Now, if you already know how to do any of these, and you want to just skip to something in particular, if you look in the description, I'm actually going to post the skip 2 times, so you can just jump ahead to whatever specific topic you want to take a look at. Maybe you're not going to sit through this whole video here. So, all right, let's get started here. Let's open up a new Mathematica page here. And we're going to start with how to create a matrix. There's a whole bunch of different methods that I could show you. Some of them will actually create matrices from functions you've created before. There's also a table function which will actually create a matrix based on an algorithm that has to deal with the different position of like whichever row and column the different numbers are in. I'm actually just going to show you two though. One is with the basic math assistant, and the other is in code form. It's going to be a list function, which is used just to input a matrix as you see it. So the basic math assistant is a really powerful tool. It's great for people who have almost no experience with Mathematica or code for that matter. They hate dealing with code and just kind of want to put things in the way they see it. That's what this tool is for. To get to it, you just go to palettes up here. Basic Math Assistant is the first one you see. So just click that, and here you get a table here with, it's just a huge template. It's got pretty much everything, every basic function you could want. So it's really, really cool. To get to matrices, you're just going to go to Basic Commands. It's usually open, but you might find it like that, minimized. That's alright. You just click on it. It'll open right up for you. Just go to the matrix thing here. You'll see right there. And to create a matrix, you just click this guy right here, and there you go, matrix. Type in whatever you want, 2, click on each box, 3, 1, 2. You got a 2 by 2 matrix. If you want it a little bit bigger, just go to the right. You're going to see add row and add column. You can add as many as you want, rows and columns, and just go crazy with it. Put as many numbers in as you want till you get whatever matrix you, didn't mean to do that. Put in whatever matrix you want here. Alright, so we're actually going to create a 3 by 3 matrix. So add a row and add a column. Let's say 2, 4, well, that's a 3 actually. 0, 7, 6. There we go. And there's our matrix. The basic math assistant actually has a few other functions for dealing with matrices here. You can see like row reduce, inverse, transpose. We'll go over those a little bit later. But first, I'm actually going to show you how to create this same matrix by typing it in Mathematica language here. It's a lot simpler than most people think. If you've never dealt with code before, don't sweat it. It's pretty simple. I'll talk you through the basics here. Let's get rid of this guy here. Let's say you wanted to create this matrix. What I'm going to do is I'm actually going to type in the list command, and then I'll go over the particulars here for you. So I would actually type it in like this. 2, 3, 0. Whoops, didn't mean to do that. 5, 6, 7. 7, 8, 9. Okay. This is how you input a matrix in Mathematica. If you've never dealt with this before, there's a few cardinal rules you have to follow when dealing with Mathematica. One is whenever you're dealing with a command that's in Mathematica library, you always have to capitalize it. That's how Mathematica recognizes it as one of its own. It's like, hey, I know what this is. This belongs to me. If you don't capitalize it, it's not going to recognize it. It's just going to think you made some weird variable, and it's not going to do anything. So the command here is list. You're going to do it with a capital L. Anything you want list to act on has to be inside these closed brackets right here, these square brackets. So an empty an empty list is going to look like that. It's list and it has no input. It's just empty brackets here. Next, if you have a series of numbers, that always has to be enclosed by curly brackets. These different brackets are how Mathematica recognizes what's what. It's how it sorts it out. So for every row, you're going to put them in a separate set of curly brackets. So for 230, the first row is going to be 230 in curly brackets, comma, new curly brackets for the second row, 567, comma, new curly brackets, 7, comma, 8, comma, 9. And so this is a matrix here. So let's input this and see what we get here. You can either use Shift Enter or you can hit Enter on the numeral key on the far right side of your keyboard. Either way works here. So let's see what we got. Okay, and this is a matrix according to Mathematica. Mathematica likes to see things in list form here. I know that's not what we're used to, and if you don't like it, don't sweat it. We can actually make this a little bit more recognizable. All we have to do, go back up to our command, do 2 forward slashes, and type in matrix form. Now this is a command, so remember it's capital M, matrix, and I didn't even have to finish it. Mathematica has a whole list of possible functions I could use. Just trying to autocomplete me here. So I'm just going to click matrix form here. If you do choose to type it all the way in, notice this is a capital F right here, so be careful about that. Mathematica likes its capital letters. If you type it in lowercase, not going to work. So let's see what this looks like. And there you go. This is exactly the same matrix that we had above. So if you don't want to go all the way to the basic math assistant and you want to type it in, which with some practice you can actually do a lot faster, this is what it would look like. Okay, next, the last matrix I'm going to show you how to create here is actually an identity matrix, which you may have to do sometime. Obviously, you can go to the basic math assistant, or you can create a list and type in all the ones and zeros. But Mathematica actually helps us out with that. And it can be a little tedious, and they kind of threw us a bone here. All you have to do is type in the command. Whoops, there we go. There we go. We got the drop-down command here. Identity matrix with a capital I and a capital M. And if you remember, identity matrices are always square. So all you have to do, depending on however many rows and columns you want, you just type in whatever you want. So let's say it's a 3 by 3 matrix. You're going to type in 3 in those square brackets, and it's going to give us a 3 by 3 identity matrix. Here, let's put this in matrix form. And there you go. And you can do that with any number you want. Let's type in 10. And there's your gigantic identity matrix. And it's as simple as that. You don't have to go through all the tedium of typing in your ones and zeros in list form here. Okay, and that's pretty much it. It's not hard to create a matrix. Next, we are going to go into some basic matrix operations, and Mathematica makes all of those things easy. Doing it on pen and paper, you're going to have to go through a whole series of steps, but Mathematica takes care of that for us. We have first our transpose command here. So let's create a matrix M. So first, for those of you who don't know Mathematica, it's always a good habit to clear your variables before you use them. It's just capital C here for clear, and then whatever variable you're going to use. That's just in case M was already assigned a value from some previous session you had here. Next, we're going to say M equals the let's say the 3 by 3 matrix we were doing up top here. So remember, square bracket, curly bracket, 2, 3, 0, 5, 6, 7, and 7, 8, 9. Whoops, there we go. And I'm going to put a semicolon at the end of that. And all that does is it suppresses the output. What that means is if I were to hit Shift Enter and input it, it'll actually, without the semicolon, it'll actually give me the list matrix as an output. Now, I don't want to see that, so I just put the semicolon, and it doesn't do that for me. In fact, here, let me show you. There we go. See, so there's the matrix I put in. When I put the semicolon there, It just accepts that it's there and it doesn't have to show me. So there's our matrix. If we want to see it now, all I have to do is type in M, and let's put it in matrix form. There we go. Now, here's your basic commands. The transposition of that matrix, remember, is actually going to kind of flip this matrix around. All you have to do is type in transpose, put it in the square brackets. Remember, if you want transpose to act on something, it's going to have to be inside of square brackets right next to it. So I was going to say transpose this matrix. Oops, let's put that in matrix form. And there you go. It's as easy as that. Besides transpositions, we can do determinants. Which we could actually say it's just det. You take the determinant of M, and you're going to get an output. Remember, determinants are, well, 3 by 3 matrix, you're going to have to do that with the determinant by minors. But with Mathematica, you can actually just type in the command and it comes out with an output. These are all really, really easy with Mathematica. I love this program to death. If you wanted to put this into row reduce form, all you have to do is type in row reduce of M. And let's put that in matrix form. Let's see, I'm not capitalizing it, so it doesn't recognize it. There we go. And just like that, it is now in row reduce form. If you wanted to find the inverse of the matrix, most of the things in Mathematica is not hard. It's just knowing what the commands are. There's our inverse. And let's say we wanted to check that, which we can actually do. Remember, you can find an inverse using the Gauss-Jordan method. So how do we do that? Well, let's create a new matrix, N. Okay, we'll say N is equal to the matrix we have up here. And we're actually going to tack on an identity matrix to the end of it. So that way, and I'll show you what it looks like at the end, and it should look a little more recognizable after that. But it's going to be 1, 0, 0, 0, 1, 0, and 0, 0, 1. Oops. There we go. Whoops. There, forgot that close bracket. Alright, so the end result. Now, what did I mess up here? Oh, there we go. I forgot about these guys here. My mistake. There we go. Alright, so here's all the functions we were doing before. This is our matrix N right here. Now, if you remember Gauss-Jordan's method, what you're going to do is you're going to take your original matrix and you're going to put it in the same matrix as your identity matrix, and then you're going to row reduce, so that way this becomes the identity matrix, and this will actually become the inverse of what you originally had. So let's try that and let's see what we have. Oops, let's put that in matrix form. There we go. And as you can see, what we have here exactly matches up to our inverse. So you actually don't have to go through any other complicated procedures. Just type in inverse and you'll get the right answer. And we just double checked that. So you're in good shape. If you just remember the commands and you're okay. Finally, before I get to eigenvalues and vectors, I'm going to show you how to multiply matrices. The reason being, you can't actually type in multiplication the way you do numerals here. So normally you would say 5 times 3, or so there's 15. Or you can actually do 5 space 3. Both of those See, I actually didn't type in that multiplication symbol. Just by hitting space and 3, Mathematica automatically recognizes that you want to multiply it. Um, you can't actually do that with matrices. Matrices are done as a dot product. So let's let me show you how to do that right here. Let's clear m and n, and then we're going to say m is equal to a 2 by 2 matrix. So I'll say 1, 2, whoops, excuse me, there we go, list. I'm forgetting my own commands here. 1, 2, and we'll say 3, 4. And then n equals list of, let's just do it backwards here, 3, 4, 2, 1 here, sort of. And then here, we'll go ahead and take a look at these here. Matrix form. Alright, there's our two matrices. Now, if you wanted to multiply the two, you actually wouldn't say m times n. That'll give you an error. Or it'll give you like a cross product or some weird nonsense here. This is actually incorrect if you do it on paper. What you want to do is m dot n. And that will actually give you the correct answer. Let's put that in matrix form. There we go. And if you remember your matrix multiplication here, you're going to see 1 times 3 is 3 plus 2 times 2, which is 4. So the first number here will be 7. Okay, and then you're going to be 1 times 2 is 2, and then, 1 times 4 is 4, and then 2 times 2 is 1. So add them together, you get 6, and so on and so forth. So m dot n will actually give you the correct matrix multiplication. So don't confuse that with like the star symbol or clicking multiply on the basic math assistant. Speaking of the basic math assistant, all of these functions that we had gone over, transpose, determinant, row reduce, inverse, if you go back to basic math assistant here and right here, you'll actually see these here. Row reduce, just click it. Here, let me get down this way, create a new thing. Row reduce, it's already got your brackets here. You don't want to manually type in a matrix. It's much, much easier and cleaner if you type in the name of a matrix like I did before, like m equals this list. Or you can type in like this and create your own matrix. The same with inverse. It'll set you up, well here, linear solve, transpose. All of these things can be done here, including the last things we're going to be doing here, which is eigensystem, eigenvalues, and eigenvectors. All of this is in the basic math assistant if you don't feel like remembering the commands. Or if you just draw a blank, it's pretty easy to remember here. Okay, finally, we're going to be covering eigenvalues. Now, let's say that you have a transformation matrix, 2 by 2 transformation matrix A. So we're going to clear A here. Let's say A is equal to 1, 4. Whoops, wrong one there. 4, 3. And let's actually suppress that. Okay, now let's say we wanted to find our eigenvalues for this particular matrix. Now remember, an eigenvalue means that if you take the transformation of a vector, then that's going to equal an eigenvalue times that same vector. So all we have to do here is actually type in, instead of going through all the math of that, just go to eigenvalues of A, and that's actually a really, really weird number, but that's what we get here. Oh, no, I saw my mistake. I actually prepped a matrix beforehand. That's what I wanted. I wanted a matrix that said 1, 2, 4, 3. Now let's try that again. There we go. Now we get eigenvalues of 5 and -1. And now that we know our eigenvalues, not on paper, we would use our eigenvalues to actually find our eigenvectors. Remember that eigenvectors are going to be whatever's going to be the null space of your eigenvalue times the identity matrix minus your transformation matrix. But you don't have to worry about any of that at all. True to Mathematica form, all you have to type in is eigenvectors of A, and look at that. It gives you exactly what you want. Um, Remember, your eigenvectors are going to be some constant multiple of 1, 2, or some constant multiple of negative 1, 1. I mean, it can be any combination. Um, and if you actually wanted to know which eigenvalue corresponds to which eigenvector here, it's actually a lot easier, and you don't have to type in both commands here. If all you have to do is type in eigensystem of A, and let's make this a little more recognizable. Matrix form, as always, clears things up for us. For the eigenvalue 5, you have an eigenvector 1, 2, and for the eigenvalue negative 1, you have the eigenvector negative 1, 1. And that just about wraps up everything I have to talk about in this tutorial. Obviously, like I showed you before, you can still do all of these same things using the basic math assistant. Your eigensystem values and vectors are all right here, and they work the exact same way as transpose, inverse, and everything else. But the punchline is Mathematica makes everything much, much easier as long as you know the right codes and right way to type it in. And even if you don't, you got this cool little template here. So if I was confusing about anything, or if you had any questions for me, go ahead and just shoot a comment over to me. I'll get back to it as soon as I can. Thanks for watching the tutorial, guys.